Okay, so today we move on to part 2 of lesson 8.6. Pause the video and solve the problem. See what your answer is. Now, in part 2, we see what happens when we cannot use the cross product to solve. All right, so the reason why we can't use the cross product, do you see how there's two fractions in a number? It doesn't matter if it's a fraction number. There's two things on the left and one on the right, or two things on the left, one on the right. Or even in this one on the left, but two on the right, so on and so forth. So you actually have to solve them a different way. So to solve and check for extraneous solutions if necessary. LCM or LCD comes back into play here. Do me a favor, circle your little denominators. All right, so the first thing I have to determine is what's my LCM, or LCD you might see it as, least common multiple, least common denominator. Of all my little denominators, I get 3x. Do you remember how the complex fractions, we multiply every little numerator by the LCM? It's the same thing here, all right, but they just look different. They're not complex fractions. So I'm going to take that 3x and multiply by all the numerators. All right, so I'll get 2 times 3x over the common denominator, which is x, plus 4 times 3x all over 3 equals 2 times 3x. All right. So what cancels out? The x's cancel out, the 3's cancel out. Let's see what I'm left with. The whole point of multiplying by the exact LCM is I get my little fractions to cancel out. All right, so then I get what? 2 times 3 is 6, plus I'm left with 4x equals 2 times 3x is 6x. So multiplying by the exact LCM gets it to cancel out where I have a single answer. All right. So I'll bring all the x's to the left. Remove that 6 over as negative 6 to the right. So brought 6x over as negative 6x. Negative 2x equals negative 6. Divide by negative 2, x equals 3. And that's my answer. Now, I say check for extraneous solutions if necessary. If you only have one answer, you don't have to worry about it. When you have two answers is where you have to determine that. Right? And I'll draw on the lines here for this one. All right, so circle, let's try another one. Circle your little denominators. I can actually factor x squared plus 1, right? Change it to x plus 1. Actually, I might type that there. X plus 1, x minus 1. All right? Let me circle that. So my little denominators is where I determine the LCM. Think about what your LCM should be. It should be x minus 1, x plus 1. I only need one of each. I have 1x plus 1, so I include that. I have 1x minus 1 here, 1x minus 1 here, so they only each have 1. All right, so from here, I'm going to multiply the top by the LCM, plus 1, x minus 1. Now remember, that means I'm not even multiplying them out. I'm just distributing them, attaching them to every single numerator here. So this time I'm actually going to type this out. I'll look a little nicer. So 7 times x plus 1, x minus 1, over x minus 1, minus 5x plus 1, x minus 1, equals, I'm going to move this down a little, 6 x plus 1, x minus 1, over this denominator, x plus 1. All right, so can we all see that there? I'll draw my little fraction bars. Now you'll notice, so the denominator stays exactly the same. We're only multiplying the LCM to the numerators. And this one had no denominator, the -5, so we just attach it. All right, so these go away. X minus 1s. X plus 1s go away. You can see what we're left with. I'm going to type it out first before I multiply. I'm left with 7 times the quantity x plus 1 minus 5. Are you guys okay with me foiling in this step? Okay, so x times x is x squared. Then I get -1x plus 1x, which is 0, x. And then 1 times -1 is -1. Are we okay with the fact that that's what that simplifies to? You know that makes sense, right? Because what was this denominator before we factored x squared minus 1? All right, equals 6 times x minus 1. So we're getting there. We're going to distribute the 7 to both, -5 to both, make sure it's a -5, and then the 6 to both. But once again, you see multiplying by the LCM gets rid of our denominators. So you get 7x plus 7 minus 5x squared plus 5. Be careful, I'm distributing a negative to both, equals 6x minus 6. Now combine like terms here, 7x plus 12 minus 5x squared equals 6x minus 6. And how I did that was I combined the 7 and the 5 to get 12. And now from here, I'm going to move everything over to the right. Do you know I want the right? Well, first of all, it's an x squared, so I'm going to have to factor. It's going to have to set equal to 0. But it's a -5x squared. I don't want to deal with the negative. It's easier to deal with the positive version of it. So you get what? 5x squared plus 6x minus 7x, because the 7x comes over as a negative, minus 6, and then 12 comes over as -12. Combine like terms. That's a minus there. All right, do me one favor here. I realized I made one little error. So can you guys do me one favor and go back for a second instead of me starting over? Okay. Do you see what I missed up here? I hope you guys actually noticed that and didn't make the same mistake as me. These cancel out as well, right? Does everyone see that? Sorry about that. Let's go back for a second though. So really all I have is the 6 there. See, we all make mistakes, right? I'm just as guilty of it as the next person. So fix this, it's just a 6. We'll just start from here. Okay. So I combined those. Let's backtrack for a second and move everything over now. So 5x squared becomes a positive because we move it over, minus 7x plus 6, that was left, and then minus 12. All right, so go back for a second. Like I said, sorry about that. I mean, we all make mistakes. At least I didn't solve the whole problem. It was pretty close, but you get the idea. We all do that. Okay, so from here we have to factor. You're going to have to guess and check what works. We get 5x plus 3 and x minus 2. If we do outer, I get negative 10x plus inner is 3x. Negative 10x plus 3x is negative 7x. So when I solve, you're going to get two answers. You're going to get x equals negative 3/5. Make sure this is a two-step equation. By now you should be able to solve that. And then 2. So here are my two solutions. Now it says if solve for extraneous solutions if necessary. When you have two solutions, you have to check them both out. We remember that when we check them, we plug them back into the original. All right, so I'm not going to show all the work. We did the check in the first part of the lesson, and we've done it before. But when you do the check, you plug them back in. All right, my first check when I plug in 2, I'm going to get 2 equals 2. So 2 works. And then my other check, when I plug them into a calculator, I'm going to get negative 9.375 equals negative 9.375. And that one works as well. Please, please, please make sure you know how to check them. On a test, I will ask you that. I know at this point we've seen it a lot, so you don't have to always show the work, but both solutions check out. You always have to check both of them. All right. All right, so let's do the same thing here. Not going to talk too much. Same idea. You might want to pause the video and try some of these. Circle your little denominators. Your LCM is x plus 7. So now what I'm going to do is I'm going to multiply everything up top by x plus 7. Every little numerator to get my denominators to cancel out. So I get 12x plus 7 over x plus 7 equals 1x plus 7 minus 12x plus 7 over x. X is here. And I'll have my fractions. None of my fraction bars here. All right. So cross out what's the same and be careful. Don't make a mistake like I did before. Make sure everything cancels out nice. So the first part I'm just left with 12x equals, distribute the 1x to everything. So I get 1x squared or x squared plus 7x minus 12x, distribute the negative 12, minus 84. All right, so 12x equals x squared minus 5x minus 84. Bring over 12x, x squared minus 5x minus 12x. I'm going to factor. All right. And we think to ourselves, it should be x minus 21, x plus 4. 21 times 4 is 84. Negative 21 plus 4 is negative 17. So x equals 21, negative 4. Now, do the check. They both check out. Check means I go back to the original. All right. One I make 4 equals 4. Another one I get 0.43 equals 0.43 rounded. So once again, in this case, they both check. It's not always the case. All right. So try the last and pause the video, and I'm just going to show the work for you guys along with assignments. Please make sure you do that. Okay, so hopefully you took the time to pause the video and solve. You're going to have to pause it as well if you want to check your work. We have 15 and 1, and they both check out. Make sure you can plug them back into the original one at a time to get those two checks. One will be 0.2 equals 0.2, one will be 3 equals 3. All right, so that's it for today's lesson. Homework, problem of the day, complete the following problems. I just want you to do number 9 on assignment 12.